Given the differential equation dm over dn is equal to 1 over k m over n, where k is a constant, find the general solution given n as a function of m. So we've got dm over dn is equal to 1 over k m over n. If we separate the variables, so we're going to have to put the m over here. We want k over m, so take the k up here and the m down here, and that will be equal to 1 over n. Now differentiating both sides with respect to n, this side will become k over m dm. This will become the integral of 1 over n dn. So if we integrate this, this will be k ln of m. And we're going to put a constant on this side because I want to give n as a function of m. And it's equal to ln of n. Okay, so the reason I'm putting c on this side is to make n the subject. So if I let c be equal to ln of a, which is the standard technique, we're going to have ln of m to the k plus ln of a is equal to ln of n. We can combine these two. This becomes ln of a m to the k. The k can go up because of the laws of logarithms. It's equal to ln of n. And then we end up with getting n is equal to am to the k. Okay, this has been a video to show you how to solve a differential equation by separating the variables. I hope you've understood, and I thank you very much for watching.